What if particles themselves slowly evolve, and different kinds of particles do not keep in step as the universe ages? In the energy filament theory, that is exactly the claim, and if it is right, the old belief that particle properties never change has to be upgraded. Instead of starting from equations, imagine 10 clues already sitting in data. Near us, atomic clocks made from the same atoms, placed at different heights or conditions, never tick perfectly together and always need tiny engineering fixes, as if their inner beat had been nudged. Measurements of the proton's size disagree when you probe it with a normal electron versus a heavier cousin electron. Two gold standard methods for timing how long neutrons live give to lifetimes that refuse to match. A short-lived pair made from an electron and a positron dies a bit faster than theory says, and the electron's tiny magnet is always too strong by a hair, with the same extra sliver every time experiments improve. Now look up. Light from distant galaxies is shifted toward the red like a song played slow, but also has its fine spectral lines slightly misplaced and stretched in odd ways. Faraway molecules do not have exactly the same bond lengths and vibration rates as their twins in Earth labs. The universe gets hydrogen and helium just right yet ends up with only about 1/3 of the lithium it should have. And some cosmic signals stay a bit higher or lower in frequency than expected even after we subtract known effects. On paper, these puzzles live in separate fields, from relativity to cosmology, so they are usually treated as unrelated glitches. In this picture they rhyme. The universe is not empty but a tense energy sea, and particles are not perfect points but tiny knots of filament wound up by that tension. When the overall tension shifts with location and cosmic time, the internal rhythm and locking pattern of those knots reshuffle slightly, like guitar strings that all go a little out of tune together but by different amounts. Electrons may retune first, protons follow on their own curve. Neutrons and whole molecules respond in their own way. And nuclear binding thresholds are the fushiest of all. Then the 10 clues collapse into one sentence. Particle properties evolve with the cosmic tension, and the size of the change is not synchronized across different particles and traits. Different regions and eras of the universe are snapshots of different particle versions, written into redshifts, spectra, molecules, and element ratios. The shock is not just a new formula. It is a shift from a frozen world built from eternal bricks to a dynamic universe where even the bricks are slowly changing their beat. Tap follow, share it on New Physics, Clear Universe.